Welcome to my channel. Today we are going to dive into the world of to-do list front-end design. In this video, we will cover everything from best practices to accessibility, performance, synchronization, and more. So let's get started. Let's begin our design process by considering the crucial functional requirements. The first requirement is task creation. Task creation is one of the most fundamental features of a to-do list app. This allows users to quickly add tasks without complicated interfaces, helping them stay organized and focused. Also, it helps avoid missing deadlines. The next requirement is task modification, including setting priority, tags, and due dates. It allows users to adjust their list as needed to reflect changing priorities without the need to recreate tasks from the scratch. By modifying tasks, users can optimize their work schedule, reduce stress, and increase productivity. Also, tags are useful in to-do list app for some reasons. They allow users to organize tasks by topic or project, making it easy to find related tasks very fast. For example, if user has tasks related to different projects, they can assign a unique tag to each project and filter tasks by tag. Our next, our next requirement is task deletion. It's a critical feature for to-do list app because it allows users to remove completed or irrelevant tasks from their list, helping them maintain a task list. By being able to remove tasks easily, users can ensure that their task list stays updated and avoid unnecessary complexity. Additionally, removing tasks that are no longer relevant or necessary can help users to prioritize their work and stay focused on completing their goals. Task completion is the next crucial feature in To-Do List app. It allows users to track their progress and stay motivated towards completion their goals. By being able to mark tasks as completed, users can get a sense of accomplishment and satisfaction, which can help increase their productivity and motivation. Additionally, marking tasks as completed can help users keep their task list organized and prioritize their work efficiently. Our next requirement is task filtering. It allows users to focus on specific tasks based on their priority, due dates, or tags. By being able to filter tasks based on these criteria, users can prioritize their work efficiently and avoid feeling overwhelmed by a long task list. Additionally, task filtering can help users stay on track and ensure that they are meeting their deadlines, which can help them manage their time better and increase their productivity. Task searching is the next one. By being able to search for tasks based on keywords, users can avoid wasting time scrolling through a long task list to find what they are looking for. The next one is reminders. The ability to set task reminders can help users manage their time more efficiently and increase their overall productivity. Data synchronization is the next important requirement. Data synchronization across multiple devices is essential for a to-do list because it allows users to access and manage their tasks from any device, ensure they can stay on top of their responsibility, no matter where they are. Keeping track of completed tasks is important for a to-do list because it allows users to see their progress. So the next one is task history. It also help users identify patterns in their productivity and identify areas where they may need to improve. So, until the task is not deleted, we should have ability to find it. Visualization of progress is important for to-do list as previous requirements. A graphic of the progress and also help users to identify any patterns or areas where they may need to improve their efficiency or time management skills. Users' authentication is not within the scope of this discussion, as it's assumed that the user has already signed in to the app. So we just skip it. The next step of our design is non-functional requirements. The first requirement is usability. Usability is essential for a to-do list because it ensures that the user can easily and efficiently create, modify, delete, and complete tasks. The next one is performance. Having a fast and responsive to-do list is essential because it allows users to efficiently manage their tasks without delays or lags. Slow performance can lead to frustration and reduced productivity. Additionally, a fast and responsive to-do list can help users stay organized and on top of their tasks, ensuring that they don't miss important deadlines or forget about important responsibility. The next requirement is accessibility. Ensuring, ensuring accessibility for users with disabilities is essential for any software application, including a to-do list. By making the to-do list accessible, it allows all users to benefit from its features, regardless of any physical or cognitive limitation they may have. The next one is reliability. If the to-do list is unreliable, users may miss important deadlines or forget to complete important tasks, which can have serious issues, so that reliability is essential for a to-do list. Compatibility is essential for to-do list because users may want to access their tasks from multiple devices with different operation systems. This also ensures that users can switch devices or upgrade their operation system without losing their to-do list data. The last, our requirement, is maintainability. When the app grows and evolves over time, it needs to be easy to maintain and update with new features and functionality. This ensures that the app remains relevant and useful to users, while also minimizing the risk of bugs or other issues that would affect the user experience. Additionally, easy maintainability can help reduce the overall cost and effort required for ongoing development and support of the app. Now we'll be talking about the data API and endpoints for our to-do list application. Let's begin with task creation. To create a task, we'll be using the post endpoint with the following interfaces. Title and description fields will contain task data for our task. Priority, due date, creation date, and text will allow us to filter our task. Reminder date field will notify the user about upcoming task. The next endpoint is responsible for filtering, getting, and searching our task list. In this endpoint, we will have multiple query parameters to filter and search for specific tasks. The first 5 parameters are responsible for filtering our task list, while the search field will take a string that can search by title or description of our task. Current page and limit will be used for pagination to increase app performance when we have a lot of tasks. The decision to implement search and filter functionality on the front end or back end depends on various factors. The size of the dataset, the complexity of the filtering logic, and the desired user experience are all important considerations. In cases where the dataset is large or the filtering logic is complex, front-end filtering can be slower, so it's better to move this logic to the backend. By doing so, the backend can optimize the filtering process and only return the necessary data to the frontend, resulting in faster and more efficient app. When we make a request to this endpoint, we will receive a response that includes the task entity, which contains the task ID and completed fields. Additionally, we will receive a total page fields that help us to understand how many times we use pagination to retrieve list of tasks. The next endpoint is task modification. There is no any magic. We just use task ID and put task with new data. Task deletion takes ID of task and delete it from our list. In the next step, let's talk about task visualization. It can be a helpful feature for users who prefer to see their tasks in visual form, such as graphs or charts. It's recommended to create a separate page for task visualization, and for that, we need additionally implement new endpoint to receive completed and not completed task data. This endpoint will return the data in a format that's suitable for creating graphs and charts, so users can easily track their progress and get a better overview of their task. Task reminder the next hour requirement. Long polling, server-side event, and WebSockets are three techniques used for real-time communication between client and a server. Long polling is a technique where the client sends a request to the server and the server keeps the request open until new data is available. WebSockets are two-way communication protocol where the client and server can send data to each other at any time. Server-side events is unidirectional communication technique where the server sends data to the client as soon as it's available, without the need for the client to request it. Server-side events is simpler alternative to WebSockets. For a to-do list app, server-side events will be the best option because it only requires the server to send data to the client, and it doesn't require any additional requests from the client. Reminders will look like simple messages. Desktop and mobile app will send it as a push notifications. Web client can show it as alert message. Next on our list of non-functional requirements is usability. So let's take a look at the steps we need to follow to ensure our to-do list is user-friendly and easy to use. Keep it simple. A good to-do list should be easy to use and understand. Avoid adding unnecessary features or clutter the interface with too much information. Another one is task prioritization. Allow users to prioritize their tasks to ensure they are focusing on the most important ones first. Then, add due dates. It helps users prioritize and manage their workload. Next one is allow users to categorize their tasks based on project or topic to help them stay organized. Then, allow users to mark tasks as completed. Once they are finishing, to give them a sense of progress and accomplishment. Another important feature is to allow users to search and filter tasks based on keywords, due dates, and other criteria to help them quickly find the task they need to work on. The next topic is performance. There are certain actions we intake to ensure that our app works efficiently and fast. Let's take a look at some of these action items. Implementing lazy loading for long list of tasks. Rather than loading everything at once, we should only load what is necessary to reduce loading times. You split your styles into critical and non-critical CSS. You need to inline the critical CSS right into the HTML response. It helps to serve it as soon as possible. Use virtual rolling to render only the visible tasks because it can improve the performance of the to-do list, especially when dealing with a large number of tasks. By rendering only the visible tasks, it reduces the amount of DOM manipulation required and minimizes the amount of memory used by the application. gzip and broadly are compression techniques used to reduce the size of files transferred over the internet, which can reduce the loading time of web page. Broadly is generally considered to be more efficient than gzip, so we can use broadly. Web fonts can also affect performance by increasing the page load time, if not optimized properly. By optimizing assets, the to-do list application will load faster. Server-side rendering can improve page load speed and SEO, while also providing a better user experience for lines with slow internet connections. Throttling or debouncing API can help prevent extra requests and improve performance by controlling the rate at which requests are sent. The next important topic is accessibility. Having light, dark, high contrast themes in a web page can improve accessibility for users with visual disabilities, such as low vision or color blindness, by providing options that are easier for them to read. It's important that your interface and content can be operated and navigated by use of a keyboard. Some people can't use a mouse or may be using other assistive technologies that may not allow for hovering or precise clicking. Screen readers are used by users with visual disability and providing support that they can navigate and understand the content on the page. Left to right and right to left support ensures that the content is presented in the correct reading order for users who read languages that use a different directions than the default. Use ln attribute. Adding a ln attribute to the HTML element helps screen readers and other assistive technologies to identify the language used on the page and adjust their behavior. Zoom is enabled and scaled up to 200%. Users with low vision may need to zoom it to read the content, and ensuring the page can be zoomed up to 200% helps them to access the content. By the way, 200% is a requirement from W3.org organization. People who are blind or who have low vision may have some issues when focus is moved without their permission. Techniques such as using area described by allow people who use assistive technology to more easily understand the difference between the input and the error message associated with it. The next one is site orientation. Mobile users may need to rotate their device to access content. Allowing rotation, the content should be accessible in any orientation. Users with motor issues may have difficulty selecting small interactive elements if they are too close together. Autocomplete, providing a mechanism to help people more quickly, easily, and accurately fill in form fields that ask for common information, for example name, address, phone numbers, can help them a lot. We have discussed several important requirements for accessibility and usable to-do list, but there are certainly many more that we would consider. However, for now, I believe we have covered the most important ones. From reliability perspective, I would like to discuss two topics: offline mode and managing a large number of tasks. We have already covered the second topics in the API session. But to implement offline mode, we have one interesting thing: conflict-free replicated data types. In simple terms, It's a way of designing data structure that can be replicated across multiple devices without conflicts, even when there is no consistent network connection. It allows users to work on the same data simultaneously without overwriting each other's changes. The next topic is compatibility. Having the core logic of your app written in JavaScript provides flexibility to use various UI frameworks like React Native, Electron, or just Web. Some UI part can be different. I mean, for React Native, we use some ready-made components, so this part can be a bit different. Responsive design ensures your app adapts well to different screen sizes and resolutions, while progressive enhancements allows for a better user experience across different devices and browsers. And the last topic for today is maintainability. We need to follow next steps to have good level of maintainability. Consistent coding standards. Follow consistent coding style and name it version for your code base. Break your application into small and manageable modules. Use a version control system to keep track of changes made to your code base. Write automated tests to ensure the functionality of your code base. Document your code base, including how it works, its dependencies, and its usage. Continuously refactor your code base to improve its maintainability. Keep your dependencies up to date and use a page manager to manage them. Use Rush reporting platform that provides you with real-time insight into production deployments, like Sentry, LogRocket, Datadog, etc. And the last item for today is CI/CD. CI/CD process helps improve maintainability in several ways. Early detection of issues, consistent and repeatable builds, faster time to market. That's all for today's video on To-Do List front-end design. I hope that you enjoy this video. If you're hungry for more content like this, or if there is any specific topic that brings your attention and you want me to dive deeper into, just let me know. Thank you for watching. See you.